I'm working on getting a fixed wing running PX4. This is a Flight Spear by FliteTest. Flight spelled F-L-I-T-E-T-E-S-T. Spell test the normal way. You can go to their website for instructions on how to build this. So the frame is already built out. Let's go ahead and place our components. Okay, so the first thing that we're going to do is mount this flight controller. So this is the Holybro 6C. So we're actually going just to take this and mount this right in the middle. Now, my favorite way to mount, to be honest with you, is to use Velcro. That way, if I need to take this out, make any additions to it, plug in any other peripherals, I can easily do that without, I don't know, ripping things up or having to unscrew a ton of stuff. And to be honest with you, this is a cardboard airframe, so there's not too much to unscrew anyway. Okay, so now that this is mounted in here, we can go ahead and just clip in where our servos are going to connect to. So I'll just use IO PWM out. Might switch this later, depending on how I feel. The servos are going to plug into that, but we have to talk about power. So this is going to go to the motor once we mount it on the back. And this will get power from this power modulation unit, which will then plug into the battery. So this is how the flight controller gets its power. So you can just plug this right into power uno, power one for the layman. And then you can plug in this ESC. That's right? Whoa. Yeah. So this is where our PWM out is. And if you look on the side, there'll be an S, a plus, and a minus. So S stands for signal, which is going to be our yellow. We'll plug this into two. We'll plug the other servo into 3. And then we'll plug in the ESC that we have here into 1. Ooh. Now, obviously, this looks terrible. So I'm going to take some time and clean this up. But this is essentially how our layout goes. Oh, I almost forgot. We have to put a UBEC in here to make sure that we're powering the actual servos, which we'll do here as soon as I'm done rubbing my eye. Now I'm done. So basically, you should never power your servos off of the 5 volts that are coming out of your flight control unit. Why? Because if your servos pull too much power, your FCU can shut off or never power on in the first place. And then your unit falls out of the sky, which is no bueno. So these you get on Amazon, pretty reliable. I wouldn't use them to power a dual radio, but to control servos, oh yeah. So you want to make sure that you have your pins correct. You can plug these in. Red is in the middle. Ooh. Now the question is, where is this going to plug into? This can basically go directly into the battery, or we can splice it off of this right here. And I don't know how many volts come off of this little ditty, but we're going to find out. Okay, so as it turns out, the FliteTest ESC is just connected. It's just wired directly to the output of the battery. So I'm just essentially just plugging in my UBEC right into this right here. So this works out perfectly. All right, so now you can see I've laid out more of the components. ESC is over here. I kind of routed some wires through. This is cardboard too, so you can. The great thing about this is there's a ton of room in here. Big payload bay up here, but then you can also just poke holes and stuff and route all your cables through. So here's where my Power modulation board is, ESC is up here, the 5-volt converter is down in here, and now you see I have everything wired up. Well, I guess you can't see. There you go. I have everything wired up here. So now what we're going to do is we are going to connect to the flight controller, and we are going to flash the most recent version of PX4. Actually, this is not true. We're going to flash mainline PX4 and then set up the configuration parameters and test to make sure everything's mapped correctly, meaning the servos and the motor. All right, so if you've never done this before, here's how you do it. Basically, I am going to, inside QGC, click the Q, go to Vehicle Configuration Firmware. This is when I plug it in. Plug it in, plug it in. It'll detect it. And then I'm just going to hit Advanced Settings, Custom Firmware File. I'm going to hit OK. You're going to see all of the, oh, that's great. You're going to see all the files in my downloads folder. But I just selected the mainline well, it's actually 1.17.0 beta of PX4. So that's just flashing on the board right now. I'm going to just pause this and then we're going to upload the parameters. Okay, so the upgrade was complete. We are back. And here we go. We're going to go just down to parameters, tools, load file, and downloads again. And this is from 1.16. So we'll see what's changed. Sometimes there's a lot of sometimes there's parameters that were on 1.16 that aren't on maybe 1.17, so they don't stick. But what we're going to do is we're going to hit OK. It'll say, hey, reboot the vehicle. So we're just going to unplug it, plug it back in. Yeah, see, these parameters are missing from firmware. Now there's one of two things that could happen. Now it's either that those parameters don't exist anymore, or they just weren't enabled at the time because, let's say, maybe this Pixhawk had a different like vehicle configuration on there. So now that we changed like the vehicle configuration, these parameters should show up. And as you can see here, they get pretty annoying. And there's the West Wing, because I like watching the West Wing. Okay, there we go. Load it up again. This is really just like an unfiltered, really look into how I fumble my way through setting up a vehicle. Okay, so load from file. We're gonna go downloads again. So as you can see here, now there's a lot less parameter difference because some of them were set. But yeah, we can just kind of go through and see, all right, well, what is everything set to? Like we definitely want the min and max of that. Some of these other ones just might not exist anymore. These we can probably set when we're calibrating the RC controller. These I have no clue. See you later. Might as well just keep these, see what happens. Basically, if you see some parameters that, I don't know, complains to you, yeah, exactly. So these might be deprecated. Don't worry about them too much. If the parameter file that you get is from a different version of PX4, and you can check that right here. See, this is what I'm flashing. So what I'm going to do is I'm going to resolve these mainly by just unplugging this and plugging it back in. Should be fine. But then I'm going to run through the certain checks, make sure everything's okay, and then I'll probably cut a new configuration file with 1.17 parameters on there. That way, when you flash 1.17 PX4 on this vehicle, you can just load them right up and you won't have any issues. Okay, so now I'm back to this page, and the first thing that I want to do is make sure that everything is pretty much plugged in correctly. So I'm going to turn my camera here. Is there a way that I can full screen camera? Okay. All right, maybe a halfway, maybe a medium. Well, we'll figure this out. We're going to go into actuators. As you can see here, this is where we can actually say, all right, my servo 1, left elevon, servo 2, right elevon, and the motor and stuff like that. So what we're going to do is we're going to give her some power. Now this particular UAV takes 3 to 4 cells, and I have it set at 4 right now. It's about 15 volts. So that's a good sign. You actually heard the servos move. So what I'm going to do is I'm going to unselect that, and I'm going to try to spin the motor. Okay, what happened there is I didn't calibrate the ESC first. So what we're going to do is unplug this, and we are going to unplug that. We are going to replug it in. And then we're going to use this moment to talk about West Wing. What a great show. I think that Martin Sheen is true. Oh, here we go. We're back live. Okay, so now we're going to go back into vehicle configuration, and we are going to hit power. And we are going to, because this is a PWM ESC, you have to do this for PWM ESCs, we're going to hit calibrate. And then it says connect the battery, and we shall begin the calibration. And it's done. So we're going to go ahead and unplug. Well, I guess we don't even have to unplug it. What I want to do next is actually test the motor. So let's see here. Oh yeah, that bad boy is spinning. Next, what we're going to do is we're going to test the right elevon and the left elevon. So the right elevon, you just put your finger on there, and then you just move this. Well, that's how you know that things aren't mapped correctly. Let's figure out what's going on. So here's our PWM aux and our PWM main. As you can see here, PWM, oh, that's what it is. So main 1 is for the left elevon, main 2 is the right, and then main 3 is motor 1. So I have the pins incorrect on here. Now what I can do 2 things, right? I can actually move around the pins on here to have them mapped correctly, or I can just go in here and change them. I'm going to go ahead and just choose to unplug this, because we don't want any power going through this. And I'm going to move them around. So I need to move motor 1 to 3. And I know this is boring. Well, maybe I can make some commentary on this. Oh, we were talking about the good old Martin Sheen. Martin Sheen. God, I mean, can you ever imagine there's another president like him? Like, he is America's president. All right, so this is right. So right elevon should go into main 2. Is how we have it set up right now. So that means that left goes into main 1, right goes into main 2. And you know what we have to do now that we changed all that? Is we have to recalibrate our ESC, unfortunately. But that's okay, because we know how to do it. We're good at this. We've already done it once. We've already messed up on it once. It's 2 failures. 3rd time's the charm. Power. Calibrate. Release your inhibition. Feel the Release your inhibition. All right, here we go. So we're gonna now try this again. We're gonna hit this. No props are connected. Oh yeah. Oh yeah. All right, now we're gonna try the right elevon. Well, that didn't do anything. What about the left elevon? Okay, left elevon works. Did I plug it in wrong? Hey, it helps when you plug these things in right. Now, I should really unplug this from the power, but I'm making content, to give the people some entertainment. So right is working, left is working as well. Awesome. So now what we can do is we can probably hook up an RC controller. So as you can see here, I have my Ghost radio connected into the PPM/S-Bus RC. I am connected, and we can confirm that by going to the radio tab on QGC and see these over to the right. So once you see those, you know that it's kind of connected, and you can wiggle the sticks and ensure that everything is good to go. So I'm just going to go ahead and start calibration. Oop. Oh man, I messed up something on my controller. Start calibration here. So I'm just going to make sure the stick is all the way down, just like in the thing over here. I'm going to hit next. Now I'm just going to walk through it. Bam, bam. Yep. And yep. That one up, that one down, centered. I'm just going to toggle the switches. Whatever. And then I'm going to hit next, next, and I'm all set. Now, next what I'm going to do is I'm going to connect the telemetry radios. So this is actually how we get Mavlink packets through. This is how we're going to control the drone, but this is how we're going to connect to QGC to get Mavlink packets through. So I'm not even going to pause the video. I'm just going to do it. We are so easy. We're just going to connect to JST. We're going to connect into Telem 1. I should really power down the drone, but I'm not going to. Now you'll notice that nothing's actually communicating because I have to restart it for it to happen. Now, people don't always know this, but you can actually update the firmware on these telemetry radios. So I'm going to actually unplug this and show this right now. So I'm going to disconnect from my vehicle. Hit disconnect. And I'm going to do the same thing to update this as I did to update the firmware on the vehicle. I'm going to go to vehicle configuration firmware. I'm going to find my micro USB cable, and I'm just going to plug it in. And as you can see here, it says it found the Seek radio. There it goes, downloading the firmware. I'll pause while this happens. All right, and as you can see, it says upgrade complete. So I'm going to do the same thing for the other telemetry radio that I have here. Oh, I don't know why it said that, but whatever. And it's going to start the whole process over again. Okay, now that we have updated the firmware on both of our radios, I'm going to go ahead and plug this in, the telemetry radio. And I don't have to change any settings because they're already set for this Telem 1 port to talk over 57600 baud rate. Mavlink messages are just streaming through here and then to the other radio. So I already have this one plugged into my computer. I guess I just updated the firmware, so let me just go ahead and reestablish the connection. Just going to set this aside. And then I'm going to power this. Now I'm powering this with the actual power so that you can see it's not just the Mavlink isn't coming from the Pixhawks when I plug it in. So if I lower this, oh, it's telling me the access is denied. Oh, it found it. So yeah, so you see the parameters are taking a little bit longer because these radios are just so close to each other. There's a lot of noise. People forget that there's a lot of noise on radios. Uh-oh. Parameters are missing from the firmware. Interesting. CBRK airspeed check. Missing parameters. Well, we'll figure that one out later. Anyway, you can't have these things. Sometimes getting a little bit of space helps these things communicate because they're shouting at each other like they're trying to communicate over far distances, right? So getting a little bit of space helps. But so yeah, now we are communicating with the drone, telemetry over the Seek radios, and RC over the Ghost radio. So if we want to plan a mission on QGC, we will upload it via these radios on our map. And then if we want to take over manual control, we'll be using this. Now you can actually just plug in a joystick, like a Logitech controller or an Xbox controller, directly into QGC and control it just over these telemetry radios. But I really like having this in the loop. Lower bandwidth, you know, but you don't want your manual joystick commands to have any latency or get kind of clogged out if the telemetry between these two radios like increases. Also, what you can do is you can go into here, and if you look at this Mav 0 mode, you can actually set this to like minimal. There it is. And so you can change the types of Mavlink messages that are coming through here. So for example, if you're like, oh, I want to do manual control, you can change it to a Mavlink mode that doesn't shoot over as many Mavlink messages, so your manual controls will go through, if that makes sense. Okay, so here's how I mounted the GPS. I essentially just put it up front right here, routed it down and in, plugged it right in. You'll notice the telemetry radio is now in the back, and then my RC controller, I routed out the antenna over here. So yeah, I was a little hesitant to put the RC right next to the ESC. Usually when you're talking about radio signals and power, they don't mix very well. You don't want to put any antennas or really anything that you're doing with radio next to power. But you know, this airframe costs $40, so it's going next to the power. I put some tape there to keep it away and made sure I routed everything so they wouldn't touch as much. But you know, that is it. That is it for that. And here's what we can do now is we can connect the battery and actually run through the calibration, see what we get.
So now we can worry about attaching these servos to the actual ailerons, flaps, flaperons. Flaperon's the right word. So here's basically what I got. So it should come with rods that you can put in here. Mine got lost. Not in the mail, just into the ether, apparently. So I ordered these. Now, when you're putting these in, I bet there's like a million different ways that people do this. This is the best way that I found, which is you basically give your UAV power, and you make sure that, notice how I don't have anything on there right now, right? So these are in kind of like a neutral state. And a neutral state, if we go into actuators, you'll notice that minimum 800, maximum 2100. The disarmed, which is right in the middle, is 1450. So these are disarmed right now. Let me relaunch this. These are disarmed right now, so they're right at 1450. And we can actually double check that. We go into Analyze Tools, Nav Inspector, and then I'll go all the way down to Servo Output Raw. See that both the servos are at 1450. So goody for us. So now we are going to basically put this in the middle. Try not to have any offset on it. Sometimes you can't prevent it. And we're basically going to, I already adjusted these, but like you want the disarmed state so that the flaperon is level with the wing. And if I'm wrong about this, somebody in the comments is gonna comment and say, that's wrong, and here's why you're wrong, and you're an idiot. And that's okay, just as long as we get the right answer. Then you realize that you put on the wrong servo. You look around and find the right one. You put it on. And you lock it in. And now you can give it a whirl. So I'm going to test this servo up and down. Cool. And then you are going to do the same for the other side. Now, you want your, whatever sticks, rods, to pretty much like match each other. But the most important thing is when they're disarmed, they're at the same, they're level with the wing. That's what you're looking for. At least that's what I look for. And if need be, you want it, if you can't get it perfect, you'd rather have them aim just slightly up. So that way when they're, when it's just flying level, when you release the sticks, at least you're going up instead of flying down, or even on launch, it's up. Now, again, somebody's gonna go in the comment section, probably tell me that I'm wrong, but this is what this is based on experience. So I'm gonna go ahead and do the other side. Ooh. Again, I had to buy rods, so they're not perfect, which is fine. I just drill a little hole. And I just nick myself ever so slightly. And notice how, I don't know if you can see it, but like the plastic tooth is on the top. Just in case it becomes unhooked, it doesn't fall out and disconnect. Well, that makes things easy. Yeah, keep in mind you can always just pop this off. And just shove it on. And then make sure to put the screws on top of these so that they don't pop off mid-flight. It's all about making sure that Things don't come undone mid-flight. The RC and activity line. Oh. Sorry, you can't see what I'm doing. Do the other side. Okay, now that's about right. Now we're going to move on to the next step, which is confirming that these are actually mapped correctly. We have everything installed for the flaperons. Now what we want to do next is make sure that everything is mapped correctly. So apparently I'm already on. Or just the servos are free. So when I pull back on the sticks, the nose should pop up, right? So when you pull back on the stick, it should go up. So if you think about it, I pull back, the flaps raise, and the airflow is going to push the back of this wing down, which will make the front of the wing lift up. So that's correct. And similarly, when I push down, it's going to make the back of the wing pop up, push the front nose down. Now, when we turn left, when I get to the other side of this, it always helps to be in frame. So when I want to roll left, it's going to push the back of this wing down, right? This raises up, pushes the back of the wing, or pushes this wing down, which will cause us to roll left. And notice how this wing over here is going down, this one's pulling up. So that's correct. Same thing on this side. Now maybe you're worried about the bow, and this is a $50 drone build. I don't care that much about it. Roll right, roll left, roll right, roll left. Up, down. You want to give it a test and make sure nothing's popping out unexpectedly. And we're all good. All right, let's calibrate some drones. So, first thing that we're going to do is come over here, and we might as well start off with just level horizon. Just make sure it's on a flat surface. Your drone's on a flat surface, which it is. Click that, easy. Gyroscope, next. Boom, easy. Now we're going to do the compass. So our autopilot orientation is 270 degrees here, which makes sense, right? Because this is 0, this is 90, this is 180, that's 270. Hey, maybe what help if I enlarge this? I act like I have a cameraman following me around. Oy. It's at 270 because that's 0. That's 90 degrees. That's 180. So this is 270. North, east, south, west, 270. So if you see that and you're like, oh, the autopilot is rotated 270. Yeah, it's meant to do that. So we can access the side. So it fits in the aircraft. All right, let's go ahead and calibrate this bad boy. So what am I doing? Compass is the worst one. So you're gonna leave it. It's gonna detect the orientation. You're just gonna spin it around. Now I have a USB attached, so I can't make a full. I can't just keep doing 360s. But you're gonna want to just unwind it. This is how I do it, and then I'll flip it upside down here. And start rotating it. As you can see, you don't have to do a full 360. But it helps to do one of these, do one of those. Let's see, what do I got here? Oh. Okay. Alright. All set there. Okay. And then if we go back over here, you can see that is about right. You can do a little sanity check. You know, you can point it, let's say south. Be like, alright, yeah, that's about right. I mean, in this scenario, it's southeast, but and you can rotate it, and then just make sure that you don't have any wander on there. And I'm talking about the compass that we can see right here. So as you're holding it, you want to make sure that it's not wandering all over the place. You know, if you set it down and you know it's doing this, it's kind of doing that or slowly wandering, there's a problem. Anyway, so that looks good. Our GPS looks good. It says emergency on the battery because we don't have one connected. But we look to be good for a flight test. The last thing I think we need to do is just very quick map our flight modes. So you can see here, I want channel 7, so let's stay on there. 7, manual, look, RC. Keep in mind this is the mainline build that I'm working with, so it might not be the most polished. As you can see here, as we're switching the RC, we're able to change different modes. I always like to map a kill switch, especially when testing out experimental hardware for the first time. So I'm going to have that be 6. What's my arm switch? And then we're good to go. So, like I said, we want to make sure that we're able to change modes, especially have like a fallback, right? If you're testing out mission mode, make sure that you can fall back into, like manual mode or stabilized flight mode. And then I like to map the kill switch. Obviously, you're going to want to be very careful when you hit the kill switch. It's like very last resort, emergency type deal. But we're going to mount the propeller, make sure that it's spinning the right way, and then we can get this test fly. But mounting the propeller next. Okay, so now we're mounting the propeller. So let's go ahead. Let's give this bad boy some power. So we have these propellers. There are propellers. I don't know. All right. I don't know. Not perfect. I think they come with some. These look good. They fit. Looks like they have a high attack angle. Who cares? Who cares? People are going to care. All right. So what we're going to do is we're going to arm this thing. And then it's going to complain at us. It's going to say, hey, you don't know what you're doing. All right. Then we're going to go to stabilized flight mode. I'm going to accidentally bump into mission. You know what? We're not going to do this through the controller. Yeah, no, the receiver's still. We're going to go in here, we're going to do vehicle configuration, and we're just going to go to actuators, and we're trying to get just a spin. So you can kind of touch it, and it's spinning this way. It's spinning this way. Let me show you what it looks like. You just want to put a little finger on there. You can tell which way it's spinning. Okay, so if it's spinning this way, this is, you just have to think through this, right? You want wind to blow out the back. So, if we spin this way, it's going to take air and push it out the back, so we need to mount the propeller like this. I guess you can take another propeller and say, alright, well, if it spins that way and I mount it that way and blah, blah, blah. Ain't nobody got time for that. So it comes with these kind of O-rings, if you will, that you can put on here. I guarantee that RC people are behind the screen, if they're watching, if they're still watching, they're just cringing. You can see which one fits the best, because you want this to fit tight. Or, you know what, you don't really need an O-ring. Yeah, you do. Just pick a slightly looser one. Take this, throw it on there. Now here comes the important. Here comes the important part: is tightening it down. So you're going to want a Allen key, Allen wrench. And usually you have one right by your desk, but you don't at this moment. So you look like an idiot, and then you got to go get one. All right, now we have one. We can just take this, push it through. Tighten it down. Okay. Now the final test is to just make sure that this is spinning the right way. So what's going to happen is I'm just going to give this a little gas. We should feel the wind come out of the back. Is this dangerous? I mean, yeah, but you know, whatever. There's more dangerous things that you can do. Careful. Yeah. And I definitely feel the wind. So we are all set. Last thing that we are going to do is put a battery in here, lock it down with some Velcro. I like Velcro. Just shove it there in the nose, or excuse me, put it right here. Whoop, you can't see. Gonna put the battery right in here, right in the battery bay. I just lock it down with some Velcro. Or you can put straps in here if you want, make some holes and put straps. But I'm gonna apply this with a 4-cell, I believe. Yeah, 4-cell. Yeah, so let's go out there, let's test it, see how it goes.